Good day, dear friends. I'm Pranasish, and I'm back with another problem related to an accelerating wedge block system. This is a wedge having a rough inclined surface with an angle of inclination theta. It's a block of mass m. The coefficient of static friction between the block and the inclined surface is mu s. In the last video, we found an expression for the minimum horizontal acceleration of this wedge, for which the block could just be prevented from sliding down the inclined surface of the wedge. The direction can again be obtained by clicking the link given in the comment box. Now we are going to find the maximum horizontal acceleration of the wedge, for which the block can just be prevented from sliding up the inclined surface. Let the maximum horizontal acceleration of the wedge be A max. It's directed to the right. Now let's analyze the forces acting on this block. The force of gravity acts on the block vertically downward, and it's given by W. W is equal to the mass of the block multiplied by the acceleration due to the Earth's gravity. The pseudo force experienced by this block in this non-inertial frame of reference in the form of the wedge is given by F, and the magnitude of the pseudo force experienced by this block is given by F is equal to the mass of the block multiplied by the horizontal acceleration of the wedge. Now let's identify the two very important angles. First, the angle between the normal to the inclined surface and the vertical, and it's theta, since the angle of inclination is theta. The angle between the horizontal and the inclined surface is theta. The magnitude of the component of the force of gravity acting on the block in the direction normal to the inclined surface is given by W1, and W1 is equal to W cos theta is equal to mg cos theta. The magnitude of the component of the pseudo force in the direction of the normal to the inclined surface is given by F1, and F1 is equal to F sine theta is equal to M A max sine theta. The normal force exerted on the block by the inclined surface is denoted as N, and this normal force balances these two components of the forces. Thus, we can write the normal force N is equal to W1 plus F1 is equal to mg cos theta plus ma max sin theta. The component of the force of gravity in the direction parallel to the inclined surface is given by W2, and W2 is equal to W sin theta is equal to mg sin theta. The component of the pseudo force in the direction parallel to the inclined surface is given by F2, and F2 is equal to F cos theta is equal to ma max cos theta. The force of static friction acts on the block down the inclined surface as the block is on the verge of sliding up the inclined surface. Thus, the force of static friction F is equal to the coefficient of static friction multiplied by the normal force exerted on the block by the inclined surface is equal to mu s. In place of n, we write this expression mg cos theta plus ma max sin theta. Since the block is stationary related to this wedge, we can say that all the forces and the components of the forces acting on the block along this inclined surface are at equilibrium. Thus, we can say that F2 is equal to the sum of W2 and F. In place of F2, we write ma cos theta, ma max cos theta, and in place of W2, we write mg sin theta, and in place of F, we write this expression mu s mg cos theta plus ma max sin theta. Now from this equation, we can find the expression for the maximum horizontal acceleration of this wedge, for which the block can just be prevented from sliding up the inclined surface of the wedge. And thus A max is equal to sin theta plus mu s cos theta divided by cos theta minus mu s sin theta multiplied by the acceleration due to the Earth's gravity. Now, in place of mu s, the coefficient of static friction, we can write the tangent of the angle of friction. And the angle of friction has already been defined in the last video. Thus, we can write sin theta plus, in place of mu s, we write tan the angle of friction, which is denoted as lambda, cos theta divided by cos theta minus tan lambda sin theta multiplied by g. Now, multiplying both the numerator and the denominator by cos lambda, we get sin theta cos lambda plus cos theta, and then multiplying tan lambda by cos lambda, we get sin lambda divided by cos theta cos lambda minus multiplying tan lambda by cos lambda, we get sin lambda, and we write it after sin theta, sin lambda multiplied by g. And therefore A max is equal to cos theta sin theta plus cos lambda plus cos theta sin lambda is equal to sin theta plus lambda, and cos theta cos lambda minus sin theta sin lambda is equal to cos theta plus lambda, and sin theta plus lambda divided by cos theta plus lambda, we get tan theta plus lambda multiplied by the acceleration due to the Earth's gravity. And this is the expression for the maximum horizontal acceleration of the wedge, for which the block can just be prevented from sliding up the inclined surface of the wedge. And there's another expression, this one, if it is not so easy to remember, at least we can remember this expression. And the minimum horizontal acceleration of this wedge was found to be A minimum is equal to, in the last video we obtained the expression A mean is equal to tan theta minus lambda multiplied by the acceleration due to the Earth's gravity. And in this way, we find the range of the acceleration, horizontal acceleration of the wedge, for which the block can be prevented from sliding down the inclined plane and sliding up the inclined plane. Thank you, and wait for the next video.